In this tutorial we're going to use the displacement time graph to prove how we derive suvat 4, which I'm going to do in red. Okay, let's just label up the y-axis because they've been clipped off. The u is the initial velocity, and the v, which projects from there, is here, and that's in meters per second. So let's just put the suvat headings up here as well. S-U-V-A-T. Now, as you can see, we have 4 of these suvats formulae. Now, the formulae have different variables missing for different situations. So you should always be able to find the right suvat 1 to 4 for any of the questions or problems you're faced with. So let's have a look at what we're trying to do. We are looking at an S. S is displacement. It's the first one here. And what we're trying to do is we're going to use the area in these compound shapes, which are made up of a right-angled triangle and a rectangle. So let's see how that goes. We've got everything that we need. We've got all the dimensions. We just have to deduce them by reading the graph. Okay, so first off, first thing to do would be to find the area of the triangle, which I'm going to denote just by putting a little triangle. Like that, okay. So the area of the triangle is going to be base times height divided by 2. Let's write those in. So base times height divided by 2. Which we then need to put the right variables in because we don't have a base or a height. We've got times, u's and v's. So the base times height is going to be, the t is going to be the base always, times the height is going to be v, the final velocity, minus the initial velocity, which gives us this height of the triangle here, as you can see, all over 2. Okay, so that's first part of it, and we can already see we're getting the correct variables as a direct result of looking at this graph. The next area we need, I will denote as a rectangle, oddly enough. We're going to add them together. That's a rectangle, by the way. And that's just going to be base times height, so it's really a lot easier. Base times height, which equals u times t, the initial velocity, times the time. Okay, the next stage is to add the 2 shapes into a composite shape. Triangle plus rectangle. And that's going to be and we've got a little bit of fractional algebra. Okay, so let's just get this written out. V minus, we've already derived this from the graph. I'm just copying it out again to put it in the right form, over 2 plus ut. So we're going to have to make common denominators, so let's do that. It's pretty straightforward though. It's just the same as you would if you were doing grade 6 fractions, but with letters. Minus ut over 2 plus 2ut over 2. Now the first thing we can do is start to cancel. So we've got a 2ut over 2 and a ut over 2 here. So rather than write them all out, if I just get rid of the 2 and get rid of that, that's got rid of and cancelled those 2 terms and simplified them. The next thing to do is to rewrite it so you can see what on earth is going on. Vt over 2 plus ut over 2. Okay? So, and that's still s. So then you can take the t out, in fact, and as a common factor, and which equals t times v plus u over 2. And if you look, we've got s equals v plus u times t divided by 2. It is number 4. So just to celebrate that, I'm going to put a number 4. Well, hey.